Okay, we're going to do this question 1, but I've just got to finish off the notes from the preceding section in 2.9. We got up to getting these three properties, and we were looking at these things, so I'm just going to do these quickly. What is the log A of A? Well, basically unwrap that log, and this swings down and hits this in the air. So A to what power is A? Well, it's power 1, isn't it? Oops, it's power 1. Yeah, so this value is 1. Because of this. And also, if you unwrap this, log A of 1, then what is that? Well, unwrap the log, A to what power equals 1? Well, clearly it's the power 0. Anything to the power 0 is 1. We're dealing with A greater than 0 in the context of logs. Okay, so that's fine, and we know that log A of 1 is 0. Okay, good. So, with those thoughts in mind, then we can label these as 4 and 5. Our properties are logs, which we'll keep. And we can just write down log 3 of 3, can't we now? It's just going to be 1. What power do you raise 3 to get to 3? What power do you raise 7 to get to 1? You raise it to 0, don't you? Here you raise 7 squared. C, you raise it to the power of 5. So the answer is 5 for that one. This is change of base rule. Most calculators, on our calculator, we have a change of base button here, which is the calculator we recommend. And you can use, so you can tap that in here. So log 10 of 8, if you wanted to use that logarithm function, 0.903. And what's log 8 of 10? If you've got that, what is log 8 of 10? Well, again, you could have used the log 10 button, which is here by default. But if we use log this button, we can also just type in any base logarithm here. Log 8 of 10 then is 1.17. 1.107. So that's 1.107. But this change of base formula, which I'm not going to prove, it's just something for reference. Because we've got this functionality in our calculator, we don't really need to do it. But you can actually use that logarithm if you look at it. If you put n as b in this formula, so you can write log a of b then will be log b of b, see it? N is b over log b of a. And log b of b is 1, so it's 1 over log b of a. So you get this property that follows. So all you'd have to do is just do log 10 of 8 is 1 over log 8 of 10. Or log 8 of 10 rather is 1 over log 10 of 8, and we could have just used, so it would be 1 over log 10 of 8, and that's our standard log button, log base 10. And you get the 1.107. But we've got that functionality on our calculator, so I'm not going to worry too much about that. If I'm doing log 8 of 30, I'm not going to use change of base, but we could use this formula here and put it in terms of log 10, couldn't we? Let's just see what it is in practice, just using the formula then. So it'd be log 10 of the top number, log 10 of the 30, which you could tap in, and log 10 of the bottom number 8. And then you could tap it in the calculator that doesn't have log 20 base and get the same number. Check it out if you want to. So we're working out log 8 of 30. Check that you get this value, log 8 of 30. 1.634. And you can check that this actually does on log base 10s equal that number. Okay, good. 636 I've got. Well, you get inaccuracies when you do. If you don't keep it very accurate, then you might get some inaccuracies in the decimal place due to calculation errors. But that's not wrong in principle. Okay, y equals a to the x then. For a greater than 1. Here's the curve of y equals a to the x. There it is. And you get like different curves. And then you get curves like that. And this might be 3 to the x, 2 to the xa, 1.5 to the x. So there's our curves then. So we've got that. This is for a greater than 1, as we said. If a were less than 1, then you'd have a curve going the other way. This would be for a less than 1. So that's what these curves look like, just from a pictorial point of view. Now the logarithm, if you're drawing the logarithm, which I'm going to put below here, if you wanted to draw that, the typical shape of a log curve comes up like this. Log 1 is 0, and it goes up like that. Okay, and this is the log function. So you can see that one is the inverse of the other, because if you pull this off the page and make the x-axis the y-axis, and make the y-axis the x-axis, pull it off, turn it over, you'll see that this curve and these curves are the same. See it? It looks like that. And if you pull out, so this is the y, and pull it off the page and turn it over, and this becomes the x, you'll see they're the same shape. So you can, one is the inverse of the other. Logs undoes indices, and indices are the inverse of logs. Okay, good. So now we'll look at some examples first. We've got a few examples to look at. Okay, so let's look at them. There's 3 examples here, so I'll just make some room and we'll have a quick look at these. Last piece of the notes now, just to touch on. So y is equal to 5 to the x minus 2. Find y when x equals 1.4, and find x when y equals 100. So first of all, y is equal to 5 to the 1.4 then, minus 2. 5 to the power, 1.4, ground level, minus 2. 7.52 to 2dp. And then find x when y is 100. Well, I'm going to rearrange it. Well, I'll put 100 in. Equals 5 to the x minus 2. So it tells us that 5 to the x is equal to, move the 2 over and add 2 to 100. And then x will equal, move the 5 to be the base number, log 5 of 102, isn't it, in log form. So log 5 of 102, 2.87. So that's that example done. The next example, let's have a look at that before we start our problem. So y equals 3 times 2 to the x minus 1. Y equals when x is equal to 2.51, and x equals what when y equals 200. So the first one then, 3 times 2 to the 2.51 minus 1. All we need to do is tap it in the calculator. 3 times 2 to the power, 2.51, ground level, minus 1. 16.09 to 2dp. Now what does x equal? Put 200 in then here. 3 times 2 to the x minus 1. Move the 1 over first, so I'll just write it here. 201 is equal to 3 times 2 to the x. So I'll just write it here now. 2 to the x then is equal to 201 over 3. Which is what? 67? Yeah, 67, isn't it? Yeah, 67. So 2 to the x is equal to 67. So then x is equal to, move the 2 down now, write it in the log form, log 2 of 67. Log 2 of 67. 6.07. Okay, good. The last one then, the last example that's mentioned, let's just create some room here before we do our exercises. So we spent 10 minutes on this now, almost. Y equals 2 log 10 of 4x minus 1. Find y when x equals 61.7, and find x when y equals 0.93. So y equals 2 log 10 of 4 times 61.7 minus 1. Type that in the calculator. 2 times log 10 is here. 4 times 61.7. Close the log, take away 1. 3.78 to 2dp. 3.78. Now we need to get x when y is equal to 0.93. So 0.93 then is equal to 2 log 10 of 4x minus 1. Move the 1 over. 1.93 is equal to 2 log 10 of 4x. Move the 2 underneath the 1.93 over 2 is equal to log 10 of 4x. Now we can unwrap the log. 4x then is equal to, move the 10 down, hits this in the air, 10 to the power 1.93 over 2. And then we can finally divide by 4. So it's 10 to the 1.93 over 2 divided by 4. Let's type it in the calculator. So it's 10 to the power 1.93 divided by 2. So that's the power. And then that number gets divided by 4, doesn't it? 2.31. Okay, that concludes the examples then. We've had a quick look at those. So let's go back to our original problem now. And we'll do these. So this one is 2 to the 0, isn't it? This one is 2 to the 1. This one is 2 to the minus 1, isn't it? 1 over 2 squared is 2 to the minus 2, isn't it? This is 2 to the 4. And then if you keep timesing by 2, you need to times up 32, 64, 128. 32, 64, 128. Another 3, 2 to the 7. This is 2 to the half. And the cube root is 2 to the third. We've mentioned these points before. Okay, that's question 1 done.